Okay, this is my distiller. Now in the other video I described it, but I didn't describe it very well, and I also didn't make a very good video, so I decided to make this video to sort of explain what was going on and maybe make it look a bit more attractive. So this is a distiller, or a vacuum distiller is how I describe it. It's very, very low tech. I designed it so like third world countries can make it. I think one YouTube user suggested using bamboo, which could probably be done. It wouldn't surprise me what the ingenuity of some people get up to, but how it works is it's like any siphon. As the water on one side is higher than water on the other side, and what happens is atmospheric pressure pushes up the water into the pipe, and because that side is slightly lower, the atmospheric pressure doesn't push it as far up into that pipe, so the water has further to fall on this side than it does on that side. Now when you get to the top of this pipe, what actually happens is the water doesn't reach the top as water, it reaches the top as vapor or a gas. Now you see what happens here is this pipe has to be above 10.3 meters. Now one of the YouTube users corrected that for me. I originally had 16 meters, but the horizontal bit, the top of the horizontal bit and the bottom of the horizontal bit have to be above 10.3 meters. Now to be on the safe side, you should probably put an extra meter on that. That's just my personal opinion. But basically how it works is, as the water comes up here, it can't go any further through the pressure of the atmosphere. Now in here would be a vacuum. Ideally you could put it together by just putting the water on the ground and lifting it up so the water drains either side and a vacuum would form. Now there's no such thing as a perfect vacuum, so the water on this side and the water on this side would begin to boil and create a sort of a vapor bridge between the two, or a gas bridge between the two. Now as the water boils on each side, they actually cool, so they would actually shrink and fall down the pipe, so the hotter water would move to the top, so problems of like the water getting colder wouldn't happen. Also, it doesn't create or destroy any energy. One of the YouTube users was complaining about that, and he sent me a personal message saying that it wouldn't work and whatnot. I'm not suggesting it creates or destroys energy. We're not dealing with the sort of gas phase diagrams of thermo equilibrium diagrams and all that. We're actually dealing with basically the heat of vaporization, or the actual energy it takes to break down the molecular structure of water. Now that can be done with the actual energy that's inside water at room temperature in a vacuum, so it would actually get cold on this side. It wouldn't actually create any energy. The water, when it reformed on that side after taking up its energy, it would give off a bit of heat back to solution. If it did get warmer, it'd be basically because the energy that it takes for water to fall from that height to that height would be converted to heat. Now that would create a very, very slow process, so you could strap a vacuum pump on that side. So here I've changed it so you can see a sideways view of it cut out, just to give you an idea of what's going on inside. Now you can see here that both these are of different height. Now that's the water column that's being pushed up by the atmospheric pressure. Now inside, the two water columns are actually the same height above the water. They're being pushed up by the same height, but in here the vapor above them is of a different height. Now what that does is it means that the vapor pressure on this side is slightly higher, and that's the idea of the invention, is that because the vapor pressure is slightly higher on this side, basically the boiling point of that water is slightly higher, so that means that more water will basically come off this side and come around to this side. Okay, the other thing I mentioned earlier in this video was that if you use a vacuum pump, now I'm just using this red sort of casing to represent the vacuum pump, which would suck the air out of here or suck the gas out of here and put it down there. It'd be a lot quicker. Now the problem with this siphon thing is it would require a lot of piping, because it wouldn't be a very quick process. But if you used a vacuum pump, it would basically accelerate the whole process a lot quicker, because the the vapor in here would always be under very, very low pressure rather than equalizing with the pressure on this side. So it would be a lot quicker process, and the water would be pushed out down this pipe a lot quicker. Now you wouldn't even need like a tank with an open top for the air. You could actually push it into water bags or anything like that, so it'd be a lot simpler. The vacuum pump would continuously suck the water out, but it'd probably cost a lot more energy to do, but it'd be a lot quicker. So if you were to make it at home or something like that, and you weren't like stuck in a situation like a third world country or something like that, you could afford to just stick a motor on it and basically suck the gas off the top of the water continuously and turn it into fresh water, fresh drinking water.